Welcome to our introduction to logic. Logic is the foundation of mathematical reasoning and computer science. Let's break down the key concepts. Let's start with propositional logic. A proposition is a statement that is either true or false. For example, the sky is blue or 2 plus 2 equals 4. We can combine these statements using logical connectives. Now let's look at truth tables. Truth tables show us all possible combinations of truth values for statements. For example, let's look at the and operation. A and B is only true when both A and B are true. Let's discuss logical equivalence. Two statements are logically equivalent if they have the same truth values in all possible situations. For example, not A and B is equivalent to not A or not B. This is known as De Morgan's law. Next are quantifiers. The universal quantifier, for all, is written as an upside-down A. The existential quantifier, there exists, is written as a backwards E. For example, we can say for all x, x squared is greater than or equal to 0. Finally, let's look at methods of proof. In a direct proof, we start with what we know and work step by step to what we want to prove. In a proof by contrapositive, we prove that if the conclusion is false, the hypothesis must be false. In a proof by contradiction, we assume the opposite of what we want to prove and show it leads to an impossible situation. Let's see a simple example using these proof methods. Let's prove that if n squared is even, then n is even. We could try a direct proof, but it's tricky. The contrapositive would be, if n is odd, then n squared is odd. Or we could assume n is odd and show n squared must be odd, reaching a contradiction. And that concludes our introduction to logic. Remember, these concepts form the foundation of mathematical reasoning and are essential for understanding more advanced topics.